everybody again. Today we're going to learn lesson 5.6 about magnetic force. Let's start. Aaron and Marcus have two bar magnets. They did an investigation to find out which magnet was the strongest. They used a plastic ruler and a metal paper clip to compare the distance each magnet could attract the paper clip. Here is the table of their results. So the poles of the magnets are Magnet 1, North Pole, Magnet 1, South Pole, Magnet 2, North Pole, and Magnet 2, South Pole. The first, second, and third readings for each of the poles were 35 millimeters, 28 millimeters, and 30 millimeters for Magnet 1, North Pole, 31 millimeters, 26 millimeters, 27 millimeters for Magnet 1's South Pole, 51 millimeters, 46 millimeters, and 53 millimeters for Magnet 2, North Pole, and 54 millimeters, 49 millimeters, and 52 millimeters for Magnet 2's South Pole. Question 1. Complete the table by filling in the average or mean readings. So the average or the mean reading for each of the poles of the magnets were 31 millimeters for Magnet 1's North Pole, 28 millimeters for Magnet 1's South Pole, 50 millimeters for Magnet 2's North Pole, and 51 2/3 of a millimeter So, these are the average or mean readings: 31 millimeters, 28 millimeters, 50 millimeters, and 51 2/3 of a millimeter. Question 2. Why did they make 3 readings for each pole of each magnet? So the reason is that they should check their answers to see if they got anything wrong. Question 3. Why did they use a metal paper clip and not a plastic coated paper clip? Well, that's because if it was a plastic coated paper clip, the paper clip wouldn't get attracted to the magnet. Question 4. What magnet was the strongest? Magnet 1 or Magnet 2? So, here as we can see, 31 and 28 are both smaller than 50 and 51. So Magnet 2 is stronger than Magnet 1. Question 5. Which pole of the magnet was strongest, the North or the South Pole? So as you can see here, 31 is larger than 28, and 51 2/3 is larger than 50. So for Magnet 1, the North Pole is stronger, but for Magnet 2, the South Pole is stronger. Question 6. What conclusion did Aaron and Marcus make about the strength of magnets? So, the conclusion might be that magnets can have different strengths, and the South and North Poles could also have of the same magnet could also have slightly different strengths, like these. Practice. Marcus compares the strength of two bar magnets, A and B. He has 3 pieces of card, 10 by 10 centimeters, and a steel screw. This is what Marcus does. Step 1. Marcus places the screw on a table underneath one piece of card. He holds magnet A over the card. The screw sticks to the card and he is able to pick up the card and screw with the magnet. He repeats step 1 with magnet B and gets the same result. Step 2. He now puts 2 pieces of card between the magnet and the screw. The screw still sticks to the magnet through 2 pieces of card when he uses magnet A and magnet B. Step 3. He now puts 3 pieces of card between the magnet and the screw. The screw still sticks to the magnet through 3 pieces of card when he uses magnet A. But when he uses magnet B, the screw does not stick to the card. Question 7. Why does the screw stick to the card when Marcus holds the magnet over the card? Well, that's because the magnet's magnetic force can go through a few objects as long as they're thin enough so that the magnetic force can still go through it. Question 8. Which magnet was strongest, A or B? Explain why. Well, magnet A was stronger than magnet B because for magnet A, the magnetic force could pass through 3 or more cards if he does the experiment more. If he uses more card, it might stick through more card. The magnetic force might go through more cards. But for B, the magnetic force only went through 2 cards and not as much. Question 9. List 2 ways that Marcus's experiment was a fair test. So the 2 ways are: he used the same screw for each of the magnets, and he also used the same pieces of card for testing the magnets. Question 10. Could Marcus have used a cork or a plastic button instead of a screw to test the strength of the magnets? Explain why or why not. Well, no, because if you do it with any magnets, even the strongest ones, they won't attract a cork or a plastic button. They only attract some metal objects, like the screw. Challenge. MagLev stands for magnetic levitation. Levitation means floating above the ground. Magnets on the tracks push and whip the train up in the air by 3 to 15 centimeters. So a maglev train floats above the tracks on a cushion of magnetic force. The magnets in the track are extremely strong and very expensive. If a country wants to use a maglev train, they have to build a completely new magnetic track. It is not possible to change an old train track into a maglev train track. Maglev trains float on air. This means there is no friction with a track. This lack of friction allows these trains to reach speeds of more than 500 kilometers per hour. Maglev trains have no wheels. This makes them quieter than normal trains. Maglev trains use 30% less energy than normal trains. So, question 11. What are maglev trains tracks made of? They are made of very strong magnets to be able to hold the train up, making it levitate. Question 12. What keeps a maglev train moving 3 to 15 centimeters above the track? So the train has some magnets under it, which repel the really strong magnets on the train track, keeping it moving 3 to 15 centimeters above the track. Question 13. Give 3 advantages to a maglev train compared to a train that runs on metal tracks. So the first advantage is it is very fast. It can move over 500 kilometers per hour. And the second advantage is that they have no wheels, and that makes them quieter than normal trains. And the third advantage is that they use 30% less energy than normal trains. Question 14. What is the main disadvantage of the maglev train? So the main disadvantage for the maglev train is that its train tracks are very expensive, and we can't recycle an old train track into a maglev train track. It's just not possible. Question 15. Find out which countries use maglev trains. So, for this question, you can answer it yourself. And this is also the end of this lesson. So thank you and goodbye.